Right, so today we're going to be looking at finding cube roots. And with cube roots, I want to just, again, show you what they do and how it works instead of giving you the verbal definition. So first, what a cube root looks like. A cube root kind of looks like a square root, except it has a little 3 in this corner, and the number would be inside. So this would be like the cube root of x. And how this works is, let me just give you an example. For instance, if I'm asking you for the cube root of 8, that means you're asking yourself, what number this time to the third power equals 8? Right? So what number times itself 3 times gives you 8? So what number multiplied 3 times gives you 8? And remember, it's got to be the same number. 1 times 1 times 1 is obviously not 8. 2 times 2, that's 4. Times 2 again, that's 8. So that means the answer to this is going to be 2. So because 2 to the third power is 8, then the answer to this question is 2. So remember, when you see a cube root, it really means what number to the third power gave me 8, and that answer was 2. So another example, if I ask you for the cube root of 27. Okay, so in that case, you're asking yourself, what number to the third power gave me 27? So there's going to be the same number 3 times, multiplied together gives you 27. So what number do you think that is? And it was 3. Because 3 times 3 is 9, and that 9 times 3 is 27. So therefore, the answer to this question, what number to the third power gave you 27? And that answer was 3. Okay, so that's how the cube root works. Now I want to give you a visual representation of what these cubes visually represent, or in cube roots. So if I have a cube and the dimensions are 1 by 1 by 1, length, width, and height, that makes one block. All right? That means that I have 1 to the third power, 1 times 1 times 1, 1. However, if I build a block with dimensions of 2 by 2 by 2, and I'm asking you, how many little blocks make up this entire image, including the ones you cannot see, but you know they're somewhere back there? 2 by 2 by 2. That would be 4 on the top, and on this bottom row there'd be another 4. So you would say this construction would have 8 blocks. And again, we're building a perfect cube. Cube because all the dimensions are the same. So this would mean 2 to the third power gave me 8. And then if I were to make a 3 by 3 by 3, not too perfect, but you get the idea. All right, a little too big. There we go. So if this one's a 3 by 3 by 3, just to give you a visual, how many blocks would be in this entire construction? Well, you see the top looks like it already has 9. So there'll be 9 on this first top, 9 along the middle, and 9 sitting on the base. So there would be a total of 27 blocks. Okay? Or you can look at 9 on the front, 9 on the second row, and 9 way on the back. So either way, this would be made up of 27 blocks. And that 27 is also calculated by saying length times width times height would be 3 to the third, which is 27. Okay. Now what I just showed you were the visual representation of what perfect cubes are. It means 8 is a perfect cube because we can build a perfect cube. 27 is a perfect cube because I can build a perfect cube. 25 would not be a perfect cube. However, if you punch it into the calculator, it'll give you decimals, which means you would have to literally take a knife, shave off some of these little cubes, shave off some other ones so that you can complete that entire box. So it'd be like 2 and some piece here by 2 and some piece here to make up for those missing pieces. But right now we're just focused on whole numbers. So 27 is a perfect square because the dimensions are whole numbers. Okay. The calculator will give you an answer, but it'll just be an ugly decimal if you try to find the cube root of 25. All right, so now I just want to go over all of the other perfect cubes. All right, so what is a perfect cube? Well, it's the whole numbers that we can use to build a cube. So if I already had a 1 by 1 by 1, we know that's a perfect cube. 8, 27, 64, 125, 216, 343, 512, 729, and 1000. Now all of these numbers are perfect cubes. What that means is if I were to buy 64 blocks, I can construct a perfect cube. And the dimensions would be 4 by 4 by 4. If I were to give you 343 blocks and tell you build a cube, then you would end up with a cube which dimensions are 7 by 7 by 7. Length, width, and height would be 7 by 7 by 7. So I'm just going to tell you what these are. 2 to the third power. This one would be 3 to the third power, 5 to the third power, 6 to the third power. This would be 8 to the third power, 9 to the third power, and 10 to the third power. All right, so those are all the perfect cubes. So now let's look at example 1. And it's best to have a list of these, that way you can reference them later to see them out already than to punch them into the calculator. So let's find each cube root. All right, and the first one's asking for the cube root of 8. And for this one, it's very simple because we already have it listed above. So what number to the third power gives me 8? That's what we're thinking. So you just look up here. What number to the third power gave me 8? And that answer was 2. 2 to the third power gave me 8. So therefore, the cube root of 8 equals 2. Okay. All right, so next one. Find the cube root of negative 27. And for this one, same thing. What number to the third power equals negative 27? Well, we don't have negatives listed on our list, but we do know how negatives work. So it looks like the digit we're referencing is going to be 3. But how do we get a negative 27? That means this would have to be a negative 3. So that means negative 3 to the third power equals negative 3 times negative 3 times negative 3. Just to show you how that works out, that's a positive 9 times a negative 3, and that does give me negative 27. So therefore, cube root is negative 3. And now let's look at C. And C says the cube root of this 1 over 64, 1/64. All right, so what number to the third power gave me 1 over 64? And for that, visually, I want to show you it's 3 fractions. That's going to give me 1 over 64. So what number times itself 3 times gives me 1? I know that's 1 times 1 times 1. So we knew the numerator is going to be 1. And this has to be the same number. So what number 3 times gives me 64? So if you go back to your list, what number to the third power is 64? And that answer is 4. So I know that 4 times 4 times 4 is 64. So again, what number to the third power is 1 over 64? And that answer is 1/4. To the third power is 1/64. Okay, so cube root of 1/64 means this question. What number to the third power gives me 1 over 64? And the answer is 1/4. Okay. All right, so it's gonna take a while to get used to what exactly the question is, and if you can answer that question, then you can record your answer. All right, so let's look at example 2. And example 2 is asking to just evaluate. And there's 2 examples. First one says 2, and then the cube root of negative 216 minus 3. Then we have another example that says take the cube root of 125, then take it to the third power, and then add 21. All right, so let's look at the first one. Like I mentioned previously in the other lesson, when we have, for example, sidebar, 2 parentheses 10, we know that that means multiply because we have grouping symbols. Anytime you have a number next to a grouping symbol, there's no operation, we know it means multiplication. And we need to get into the habit of understanding that a cube root and a square root is also a grouping symbol. It's going to group some math inside, some numbers or digits. So they're considered grouping symbols. So therefore, when you see 2 and the cube root of a number, it really means multiply, just like it did up here. Okay, so that's what we're going to interpret it this way. So when you see this here, it means 2 times the cube root of negative 216 minus 3. So just get used to that. Anytime you see a number next to a grouping symbol, it means multiply. And you also have to remember that cube roots and square roots are considered grouping symbols. So what number to the third power is negative 216? Well, let's look at our list again. 216, I know that 6 to the third power is 216. So to get a negative 216, it's going to be negative 6 to the third power. So this answer here is just negative 6. And I still have this times 2 minus 3. And then I continue. That's going to be negative 12. Multiplication first before subtraction. And then your answer is negative 15. Look at the next one. Parentheses first, and in my parentheses I'm asking the question, what number to the third power gave me this 125? So we look up here, and 125 is 5 to the third power. So I know that this answer in here alone is 5. And then I still got to raise that to the third power. And then 5 to the third power, we know that's 125 plus 21. Now, notice that we started with 125, and now we have 125 again. That's because that's another new inverse operation we need to jot down. And remember, inverse operation. If you have the cube root of something, the inverse operation is going to be the third power of that number. So this is a new set of inverse operations. And again, just like we used to have multiplying, inverse operation was dividing, or if you had addition, the inverse operation was subtraction. And in this case, if you have the inverse operation, which is a square root, and then followed by a third power, one undoes the other. So we had a cube root, and then we have a third power. These two operations are inverses. So one undoes the other, and we're back to 125, and that's exactly what happened. So anyway, let's keep going. So 125 plus 21 is 146. All right. And one last example. Example 3. And in example 3, we're going to evaluate x over 4 plus the cube root of x over 3 when x equals 192. So they're pretty much telling us to figure this out, but they're telling us what x equals, which means they want us to plug it in. So I'm going to do what I usually do when I have to plug something in, and that is to use my plug-in bubbles. And in those plug-in bubbles, I'm putting the number they gave me for x, 192. And if I could simplify this, I'm going to go ahead and do that. I'm not going to leave a fraction when I don't have to. So I know that 192 divided by 4 comes out to be 48. And 192 divided by 3. By the way, just a little trick. If you add up all these digits, 9 plus 1 plus 2, or 9 plus 1, that's 10, plus 2 is 12. And 12 is divisible by 3, then I know the whole number is divisible by 3. That's a rule of divisibility. Again, if you add up these digits, you get 12. 1 plus 9 plus 2. And 12 is divisible by 3, so I know that this big number is divisible by 3. And it's 64. That's just a little rule of divisibility. And this is a question I have to ask myself. What number to the third power was 64? And I'll show you right here. That was 4 to the third power was 64. So then it would say 48 plus 4, which equals 52. Okay. There you go. So example 4 is going to be a little more of an in-depth question on cube roots, more of an application question. And we're given a box and we're told that its volume is 125 inches cubed. Okay, and all we know is that it's got a length on each side. And it's a cube, so we know they're all the same. And they're giving us the volume, so we're asking to find the surface area. So we have to find the surface area, which means we're trying to find how much wrapping paper, the area of the wrapping paper required to cover this entire box. How many sides is on a cube? You should have thought 6, right? There's 6 sides on a cube. The 3 in the front that we see, and then there's 3 more in the back that we cannot see right now. And because this is a cube, we already know that if we know this side, that's going to be the same area for all the other 6 sides. So we need to find S. We need to know what the length and width are so that we can find the surface area. So our goal first is to find S. Then once we find S, then we can calculate the face of each side, the areas. So let's start with what we know as volume. Volume equals length times width times height of a rectangular prism. In this case, it's a cube. We know the volume they're giving us is 125. They already told us that. That was the volume. And the length, width, and height in this particular case, length, width, and height, because it's a cube, they're all going to be S's. And because they're all S's, I can just say S to the 3rd power. Now, if I want to get rid of this 3, because my ultimate goal is to get S all by itself, what can I do to get rid of that 3? Or, what's the inverse operation of taking the cube root? Or, what's the inverse operation of taking something to the 3rd power? And we wrote it down here. The inverse operation of 3rd power is taking the cube root. So we're going to do that. Take the cube root on that side. Take the cube root on that side. And these are inverse operations, so now S comes out all alone. And now we're left with the question, what number to the 3rd power is 125? And on our list, that was 5. Okay, now you did not have to do this. You didn't have to take the square root on both sides. You could have just saw and thought to yourself, what does this have to be to the 3rd power that gives me 125? Which is the exact same question you're asking when you take the cube root. Okay? So that means our dimensions of this box was 5, 5, 5. So that means this side would be 5 by 5, so 25 inches squared. Now, inches cubed because it's what fills up the box's volume, but right now we're talking about surface area. So I'm just worried about the face of this side for the wrapping paper. So if this one's 25 and I got 6 sides, I'm just going to multiply that by 6. So the sum of the area of all 6 sides. Well, I already got one side with an area of 25. So we're going to say 5 by 5 is 25 inches squared. And so all the sides, this is for one side. For one side, it's 25 inches squared. So all sides is going to be 6 times 25, which comes out to be 150 inches squared. Right? So we had a cube, volume. Because they gave us volume, we were able to figure out what the side length was. What number to the 3rd power? 5. Now that we know the side length, we knew that 5 by 5 is 25. And since we only have one side here being 25, we know that there's 6 sides total, or 6 faces on the cube. So we multiplied it by 6 and we got 150. There you go.